So here we are with another of Alan's sets, and it's a rather immaculate Danita 1240. Certainly more immaculate than the ones we were looking at, which had been donated. And we've got the original mic, which is even more fun. So it's had an intermittent fault. He sorted that. It was a dry joint because of some corrosion. Danish design by Steen X, and I've not got the right glasses, but that's about what it says. So we'll open this up. So it should just be a retune and test. He said in his little note there's another set on its way to me. So we need to make sure this mic gets photographed so that we all know what it looks like. This isn't that clear, but yes, we can see it's been corroded at some time. It's a few weeks since I've done one of these, so I've totally forgotten what's what. I do like sets that don't have meter. Right, we are powered up, but I can't see anything. Oh, there we go. Right, see whether it works in PA. Testing 1 2, testing 1 2 3. Beautifully. One box we can tick off. That's another box we can tick off. Right, let's get the test equipment plugged into the aerial socket. And let's see how many watts it's doing. Picture in picture on. And it's doing, about 3.05 watts. So let's say it's doing 3.05 watts. And then we'll go to channel 1. And it's doing 3. Of course it might be warming up. And then channel 40. As it warms up, and that's 3.05 as well. As it warms up, the power will drop. Now, because this is PR2794, In other words, the next generation of UK, not to be confused with PR27 GB, which is the CPT, or PR27 97, which is the 80 channel. Good. So it's UK, but it doesn't need to have low power. Transmit current is 919 milliamps. It doesn't have a meter lamp because it doesn't need to have one, does it? The sockets on the back work, both of them. It doesn't have a meter. That's filling so many boxes in. Deviation, we'll look at it on here initially. Let's just wait to see we want Wallow. That says 1.5, but it may be playing up. I'll just switch the other test instrument on behind me so that it's on for 5 minutes before we need to use it. Right. VCO we won't be doing. We don't have a proper way of checking that, but we could work one out if we needed to. Let's look at the frequency. So it shouldn't be far out. 27.99. Oh, we're on channel 40 still. (27) 79125. We'll just bring that up a fraction. That's not off frequency. It's there. We go. Right, we'll dial that into the signal generator. We were doing CPT yesterday, so we'll have to move it a bit. The signal generator is at 0.3 microvolts, and we can actually hear that, so it can't be that bad, can it? So, oh, it sounds a bit strangled though. Right, we'll plug the test instrument speaker in. If I get the right socket. And let's have a look at the synad meter. Pretty good. 0.54. Naught 0.46. One 0.2 microvolts. Right, let's put back a speaker which we can both hear. Well, you can hear. I can hear the other one. I was going to carry on with the Stereo Master stereogram, the HMV, and I put the cabinet, the chassis back in the cabinet, and it blew the fuse. So I thought, oh, stuff that. I'll do a CB instead. Right, full squelch. Not far out from where I'd want it. 160 microvolts. And the threshold. Oh, that's not so good. 2.3. That would not be good enough for round scratchy corner. I'm suspecting that the detector's out. So I've no idea what does what. These are crystal filtered. PR2794 needed that. And it looks to me like the serial number plate's being changed. When I was at Compass Communications in Bradford in the late 90s, there's been a couple of occasions where business two-way radios have come in, and the person says, I bought this, and I wonder if you could put it on the frequency of the firm I work for, you know, like a taxi firm or something. So I look at the back, and the serial number had been missing. So put it on the reader, and the serial number was in the EEPROM or whatever. So go. I'll put a new serial number on the back for you. Then I'll put it in the computer in front of them. Oh, it's come up as stolen off Meals on Wheels. I remember that one. I bought it in good faith. Oh, right. Well, we better tell Meals on Wheels we've got it back for them. Right, let's see if we can get something more out of this transmitter. Did we... As I've totally forgotten, it's a few weeks since we did one of these. Probably that's going to be deviation, because it's where modulation would be if it was AM. But it could also be power, which it isn't. So that looks like it's in the receiver. Just seeing if there is an overall power one. Yes, it is. That's power. So we'll put that... First of all, we'll put that to full, not because we're going to keep it on 4.4 watts, but just so we can tune this with better precision. It wouldn't survive very long at this power level, so it'll be pretty quick. That was miles out. And that one we don't touch, it's done with the spectrum analyzer. We only touch it if it fails the on the air test. So now that's a whisker away from 5 watts, it's about 4.9, so we'll drop it now to 4. That's bang on the 4. Remember, my 4 commercial watts equivalent to 7 hobby watts. So that's channel 20. So hopefully we're somewhere near at the band edges. We're dead on 4 watts at channel 1, and we're dead on 4 watts on channel 40. I was a good boy today. Right, we'll plug this into the test set behind me and see whether we can get a sensible deviation reading. Wow, it's low. And that's what we thought it was on the other one. Wallow. Right, we'll see what the Marconi test set says. I've had that on the wrong meter and didn't show you the transmit doing doing 4 watts. There you go, 4 watts. Put it on the 3 watt scale, bangs across. Right, deviation for what it's worth on this test set. Wow, it says it's 1.2, so it's playing up today. So that was actually, so it was probably about 2.2 as it was. So it was actually okayish, but a bit on the quiet side, because you've got this balance between the width being so narrow that the radio is quiet, and then once you get over that 2.5 never exceed, the width is so wide that the filters make it chop, so you only sound good on something with really, really poor filtering. So here's the thing, set with crystal filters like this, anybody over deviating or slightly off frequency and they'll chop and sound awful, whereas a set like a Fidelity 1000 with poor filtering, it just sounds wonderful. Except you get bleed over. And the current consumption now is 1.067. So we haven't gone up a lot to get an extra full watt. So I'm just going to double check the frequency because the test set is now warmed up. Yeah, it's fine. Absolutely spot on. Right, now it's time to do the receiver. So pop that down and we'll go put in the other. First of all, we'll look with 100 microvolts on the signal generator, and we'll look at the oscilloscope and we'll see. I think the detector's out. So let's see whether that's twiddleable. No, it's spot on, so the IF must be out. Okay, so back over to the cyanide meter. So put about 4 dB, so it's really a good sensitivity, because we don't want to saturate it. You can't tune it if it's saturated. We'll start at the front end, which is probably there. I'm not expecting to get much more out of this. That's right at the bottom of its travel. Put a bigger signal on for the IF. Yeah, you see the IF's out. I knew something wasn't right. Let's go back on that one. Less signal for that one. Can't see any more lurking. Get a new cyanide reading. So for 12 dB we've now got 0.36. For 10 dB we've got 0.28. And if it will do 20, it will do 20. 0.92. Right, we'll take that off and go back to the speaker we can hear. It sounds normal now, you see? Right, squelch. Now it might have fixed itself, but squelch to full. And it's now opening, it's 100 microvolts. Put the attenuator up on the inset picture. So squelch is going to be that preset, because we've done deviation, we've done transmit power, so the only one we've got left is squelch. What's that in there? Like an old sticking plaster. Right, so that's now 100 microvolts. But it still may need adjustment if the squelch is still as bad as 2.2, because I really want it to be better than 1 microvolt. So here we go, we'll turn the attenuator down, turn the squelch right down, turn the signal generator to standby, that's what the red light shows, set the squelch to threshold on the radio, yep, switch the signal generator back on. .85. So there you are, the IF being out had affected the squelch, and so it didn't need adjustment on that, it just needed the IF sorting. So we're done. Let's put the speaker back on. It's one of the quickest, that. Turn the power off for now. I've got a blob of solder gone there. I'm just going to feel this speaker as well. When they've been corroded, you don't know whether it's taken its toll on the speaker. So we're going to power it back up. Doesn't sound too bad. It looks like we've got an on-the-air test this evening then. So that's all Alan's repairs done. He did say there's another one on its way to us, I think. We've got his preamp to look at, but I know that's time consuming. I think that's going to be a Wednesday job. So I've got nothing booked in Wednesday at all. I'll turn the test gear off. Right, we'll plug it into the aerial. So it really needed some service. You know, looking at that, 3 watts instead of 4. I've gone and put that in the wrong box, haven't I? 2.2 to 2.5 kilohertz. It was 2.2 kilohertz as it was, so it's not applicable to that. Speaker sounds all right. Retune and test. Does the office know what to charge? Nicest one of these I've seen. Well, no, no, Roger. Well, no, no, Roger. Okay, that's a lovely set. Good. Right, we'll do an on-air test later on. Thank you for watching Danita 1240 UK from 1994.